All right, a few more objectives in section 2.1. This video is going to cover being able to evaluate a function using function notation, as well as being able to identify values of functions from a graph or from a table. Okay. Now, function notation, you've probably seen it in the past. It's a way of identifying an equation that represents a function. Okay. So the notation y equals f of x can be used to define a function f and is read y is a function of x or f of x. It's implied that y is the dependent variable and x is the independent variable. Okay, so let's just say we have the equation y equals negative 2x plus 3. This is an equation that represents an infinite amount of ordered pairs that when you graph them would graph to be a line. So this is a linear equation, and if you were looking at the graph of this, you would see it would pass the vertical line test, and therefore it would be a function. So because it's an equation representing a function, an alternative way of writing this, instead of saying y equals, you're going to say f of x equals negative 2x plus 3. Okay. Now again, I read that as f of x equals negative 2x plus 3, not f times x, okay? So basically this notation, it's just showing us the reader that we're working with a function, and now the notation can help us know what we want to do with the function, okay? So let's say we're trying to find f of 4, okay? That means evaluate the function with an x value of 4. Notice we've, instead of f of x, we have f of 4. That means the x has been replaced with 4. Therefore, over on the other side, negative 2x plus 3 now needs to become negative 2 times 4 plus 3. And we're simply just going to simplify the right side here with order of operations. So negative 2 times 4 is negative 8. Negative 8 plus 3 gives me negative 5. Okay, so this would be my final value. And understand what this means in terms of the graph of the function. So the 4 that I started with was my x value. I inserted it into the function, and it resulted in a y value of negative 5. So that means this particular graph has the point 4, negative 5 on it. Okay. All right, next, notice in the middle, the notation is f of x equals 3. So this time I'm looking for a value of x in this particular function that results in a y value of 3. Okay. To figure this one out, I'm going to use substitution. All right. F of x is equivalent to negative 2x plus 3. So I'm going to substitute that in on the left side there, just set it equal to 3, and now I'll solve for x. Okay. Subtract the 3 over, you get 0, divide by negative 2, still 0. Okay. So basically what this is saying is that in order for your y to result in 3 for this particular function, your x value has to be 0. Okay. Final example, now we want to evaluate the function f with a variable expression of x plus 2. So that means we are inserting x plus 2 in for x. And then we're simplifying as best as we can the right side. So I'll distribute here, negative 2x minus 4 plus 3, combine the constants, and here is my final result. Notice typically when I evaluate with a variable expression, my result is a variable expression. Okay, moving forward. Now let's look at how to evaluate functions by looking at tables and graphs. Okay, So at the top here, you have a table of n values and q values. So notice I'm not using x and y here, I'm using n and q. Typically in a table, it's understood that the values that are in the top, those are your independent values, and the values on the bottom are your dependent values. So n is like my x here, q is like my y, all right? And notice none of the n values are repeating, so that means this set of ordered pairs represents a function. So I'm going to use this notation and say that f of n equals q. Inserted value of n into the function f results in a value of q. So based off of that, let's find f of 2, okay? The 2 here is implied to be an n value. So I go into my table, I look for a correspondence where there's an n value of 2 and see how it's pairing up with a q value of 6. That means f of 2 equals 6, all right? Next, I want to know f of what number equals 7. So here, the 7 represents a q value. In the table, the only correspondence where q is 7 is right there. See how it's pairing up with an n value of 3. That means f of 3 equals 7. All right, next we have a graph to represent our function. Notice it is a function because it passes the vertical line test, and this is represented now with the notation g of x, okay? I would like to find g of 4 first. G of 4 means what value will result when x is 4. So you're going to find a spot on the graph where the point has an x coordinate of 4. That would be right here. And notice its y coordinate is 5. So that means g of 4 equals 5. And the last example, I want to know g of x equals 3 when x is what value? So here the 3 is a y value. What x value is required to make that happen for this particular graph? That would be right here, right? That point has a y value of 3 when x is 6. Okay. All right, now it's your turn to practice. You're going to pause the video, try the practice problems yourself, and then come back and check your work with mine.